Hello, friends! In this lesson, we're going to be learning about the change of volume with the change of dimensions. Let's dive in. So we have this rectangular prism, this brick over here, and we see that it has the length and it has the width. The length is 3 and the width is 2. But the height is variable. We do not know that. And I have a chart over here showing, we're going to see if we change one of the dimensions. If we change one of the dimensions, we're going to see what happens to the volume. Okay? Let's start. So let's see, if our height is 5, then let's plug in the formula. And the formula for volume is length times width times height. Or you could think of it as the area of the base. This is not too perfect of a drawing, but here. So the area of a base, this base is like a square, times the height. And in this case, the area of the base is 6. That's one way you could think of it. Or you could think of it as length times width times height, But whatever way you think about it, the answer is going to be the same because of multiplication's properties. So let's see. 3 times 2 times 5, or 6 times 5, equals 30. Now, what if we double the height times 2? Well, that would be 10. Okay, so let's plug it into the formula. 3 times 2, or 6 times 10. 6 times 10 equals 60. Okay? And as we can see, that is double of the volume that we got earlier. Well, that's interesting. We noticed that when we doubled the height, the volume doubled as well. Or we could think of it in a different way. For example, the height was always 10. If we halved it or divided it by 2, we would get 5. And if the original volume was 60, not 30, and we halved 60 or divided by 2, it would be 30. That's interesting. Let's do it one more time. Let's double the height again. So 10 times 2 is 20. Again, we're doubling. So this is 20. Now let's plug it in. 3 times 2 times 20 equals, or 6 times 20 is 120. Again, it doubled. Now, let me use another example to help you guys visualize it. Let's say, let me draw this really quickly. Okay, so let's see, if we double 2 of the dimensions, what will happen to the volume? So let's see here. We'll have, for example, it's not going to be too perfect since this looks like a square, but let's just try. Again, let's say this is 3, this is 2, and this is 5. Again, it's not scaled perfectly, but imagine it like that. Okay? So now, instead of doubling only the height of 5, let's double both 5 and 3, which would basically be, so let's do that first. Let me draw this really quickly. Again, not too perfect or scaled perfectly, but let's just pretend. Now, we doubled the 5 to 10 and the 3 to 6, but the 2 stays the same. let's finish the formula. We know that 5 times 3 times 2 equals 30. So I'm going to write 30 on top. But now let's try this one. So 6 times 2 equals 12. Let's do this. 6 times 2 is 12 times 10 equals 120. Wow. Let's see. 120 isn't double of 30. It's quadruple 30. Can you guys pause the video and think why that happened? Well, I think you probably thought about it, and let's discuss. Well, what happened here is that when we doubled both of the two dimensions, we doubled 5 and 3, we didn't simply multiply by 2, but we multiplied by 2 and then multiplied by 2 again. Basically, we multiplied by 4. That's the end of today's lesson. Hope you guys understood the relationship and the change of volume with the change of dimensions. Don't forget to like and subscribe. Bye!